right? So consider this situation. Suppose there are two blocks A and B, as you can see. Let's say they are placed on a smooth horizontal surface. They're simply placed there, the blocks are at rest. So I want you all to think of how much normal force acts between the blocks. How much normal force acts between the blocks? Try to recollect how we generally calculate normal force. There's no direct formula for normal force. We have to first consider the other forces acting on the objects. And then we write an equilibrium equation, because if the object is in equilibrium, we write equilibrium equation. If the object is moving, accelerating, then we write F net equal to ma. Okay. So from F net equal to ma, we can derive the unknown normal force. So yeah, first think of all forces acting on them to try to find out how much force they exert on each other. I'll give you all 1 minute. Okay. Do any of you have an answer? Normal force between the blocks. Fine. Aishwarya, can you tell the forces acting on the block A?
So gravity and normal force.
Gravity will act this way, m1g. Okay. And normal force, who will exert normal force on A? Who or what will exert normal force on A?
So the smooth surface.
Okay, the horizontal surface will exert a normal force. In which direction will that be?
Sir, upwards, sir, opposite to M1G.
Upward. Okay. So you are indirectly saying that there won't be any normal force between A and B. If you are saying these two are the only forces acting on A, that means you are saying B is not exerting any force on A.
So yes, sir.
Okay. Okay. So your answer to the question is 0. We'll see. Now see, when we discussed about normal force, I told you that wherever there is contact, you have to consider a normal force, because when there is contact, there can be pushing. Now A is in contact with B. Aishwarya, why did you not consider a normal force there? Or how did you find out? Or how can you say that it will be 0?
So it's because Na and M1G will balance each other, so I thought it will be 0.
Okay, fine, fine. Listen, all of you. Yeah, these forces will be acting on A. Similarly, weight and another normal force will be acting on B also from the table. B's weight is M2G, and normal force on B from the table will act this way. NB. That's fine. But the question is particularly asking about the force exerted by A on B. Now, if A exerts any normal force on B, it has to be in this direction. Okay. It has to be to the right because normal force is a pushing force. So if A pushes B, it has to push it this way. Similarly, every action has equal and opposite reaction. If A pushes B, then B will also push A. Then A will experience the reaction like this. If at all they exert any force, they have to be like this. Okay. Now, the normal forces from the surface, from the horizontal surface, they are balancing the weights. So vertically means in the y direction, the forces are balanced. Normal force balances weight of each block. Okay. Horizontally, if you consider this extra normal force, let's call it as N. Saket, tell me, what should happen to the block A due to N if N is non-zero?
It will stay at place.
It will?
It will stay in place.
If N is a non-zero force acting on A, then how can A still stay there itself?
Sir, because it will have an opposite reaction in the other direction. Sir. The same
What
way.
are you saying? Action and reaction, how will they act on the same object? I'm just asking you, if something pushes A to the left with a force N, what will happen to A?
It will move to the location.
It will have to accelerate in that direction because this N acting on A, if at all it acts, I'm telling this to everyone, this N that we considered on A, if it is non-zero, then due to that, the block should accelerate in that direction. There's no force to balance that N, right? Similarly, this normal force on B, if it is non-zero, B should accelerate to the right. So if at all A and B push each other, then they should accelerate away from each other. But in a real life situation, when you put two objects together like this, do you see them going away on their own? Two solid objects, if you place them side by side, do you see them actually pushing each other and going away from each other? That won't happen. Okay? Which means these forces should be zero. This should be zero, this should be zero. So if you simply put two blocks side by side, even though they are in contact, they won't exert any normal force on each other. Okay, it's like they won't push each other. Why will they push each other or press against each other? Okay, that will not happen. So the answer 0 is correct. There won't be any normal force between the blocks. There will be a normal force on A from the ground. There will be a normal force on B also from the ground, but block and block will not push each other. Okay, now you all tell me, if we apply forces like this, let's say 1F is applied from this side and 1F is applied from this side. Now will there be normal force between A and B? Will A and B be pressing each other or pushing each other or not in this situation? Venla, what do you think?
Yes, sir.
Definitely they will. Okay. It's like you are compressing, you're trying to compress those two objects. You are squeezing them in. Definitely they will both exert force on each other. Okay. So in this case, what happens? A will exert a normal force on B. In which direction? On B, it will be like this. And B will exert a normal force on A like this. Those two will be an action-reaction pair. Okay. Anyway, in the given question, these forces were not there. So how much normal force acts between the blocks? The answer is 0. Okay. You won't see them simply pushing each other and going away from each other on their own. That won't happen. Okay. And since the surface was horizontal smooth, you put two blocks there, they'll stay there itself. We know that from everyday experience. Now consider this situation, all of you. Again, this is also a smooth surface itself. If you want, you can consider the angle of inclination as theta. there are two blocks placed in contact on this surface and we release the system. System is released with the blocks in contact. The question is the same. What is the normal force between the blocks? Okay. Think about it, all of you. Will the blocks be pushing each other this time? Okay. Just tell me how much normal force that we'll calculate later. Will the blocks push each other if they are both released simultaneously on this incline?
So B will push A.
Okay, so you are saying B. See, if B pushes A, definitely A will have to push B.
Yes, sir.
For every action, there is an equal and opposite reaction. Okay, so you are saying they will push each other. We'll see. Others, what do you think? Saket, any answer?
I to think that they will push each other.
Okay. Aishwarya, what do you say?
So they'll push each other. Sir.
Okay. Listen, forget about this situation. Consider this itself. Or maybe just consider one block, not two also. Okay, put B aside. Consider just A. We know the ground exerts a normal force on A. Why does the ground exert, or why do A and the ground press or push against each other? What generates that push? What gives rise to this normal force? Anyone, why is that normal force arising? Like what makes A press the surface?
Gravitation force.
Gravity, correct. A's weight is trying to pull it down and the surface is in the way. Okay, so A pushes that surface, A presses that surface, surface pushes A. They'll exert normal force. A and the surface will exert normal force on each other. So generally, if you want to decide whether there will be a normal force between two surfaces or not, you should first visualize their motion independent of each other. For example, what I'm saying is, assume the surface was not there. What would have happened to A? A would have fallen down like this. So the surface will have to exert a force to prevent it from falling because it's a solid surface and that surface is not moving. It's a fixed surface, no? So it cannot allow A to move down. That's why it will have to exert a normal force. That's why they push against each other. Okay, let's consider a simple situation now, another one. Before we come to this question, let's say there are two blocks like this. These are very easy questions, but usually nobody thinks about such situations. Suppose there are two blocks like this, one placed on top of the other. They are not glued to each other or anything. They are just kept two boxes, one on top of another. Assume they are both released under gravity. Both are released under gravity. Okay. What will happen? They'll fall down. We know they'll fall down. One of you quickly tell me what makes the blocks fall down when you release them under gravity? Or when you simply release them, what makes them fall down?
Gravity.
Gravity itself. Okay, fine. Now, if I ask you whether they exert normal force on each other or not as they fall down, what will your answer be?
Yes, sir.
Why?
Because they're in contact.
No, see, just because they are in contact, it doesn't mean they exert normal. Like in the last question we saw, no, A and B, when they were side by side. Okay, it was not necessary that they exert normal force on each other. Okay, they did not exert normal force on each other even when there was a contact. Fine. So the actual question is whether one block pushes the other block or just touches the other block. Anyone? Yeah, Yusuf, if you have anything to say, you can.
So the M1 pushes M2 as it's going down, increases.
M2 is not a fixed block, no. We released both M1 and M2. M2 is also falling down. Why does M1 have to push M2? Okay, listen. Just recollect what I just said a few minutes back. If you want to find out whether normal force acts between two surfaces or not, visualize their motion independent of each other. So suppose, okay, consider only M1. Forget M2 existed. Consider only M1 and gravity acting on it. How will M1 move? Which way and with what acceleration will it move if only gravity acted on M1? Saket, tell me, if you just release M1 under gravity, with what acceleration will it move?
10.10 meter per second.
Yeah, acceleration due to gravity, 10 meter per second square. Let's just call it as g. So had M2 not been there, only M1 been there, it would have fallen with an acceleration equal to g. Now consider only M2. Okay, I'm telling this to all of you. Consider only M2. If you release it under gravity, we know it will also accelerate downward with an acceleration of g itself. Not more, not less. Okay. Both will have the same acceleration. Okay. In fact, let me copy this arrow. Acceleration due to gravity will be same for both of them. If you call it 9.8, it's 9.8. If you take it as 10, it will be 10. But it will be the same for both. So if both of them naturally have a tendency to go with equal acceleration, why will M1 push M2? Is M1 trying to go faster than M2 that M2 is coming in its way? No. Both are trying to go at the same rate. No, they will go at the same rate. Why should they exert normal force on each other? Are you all convinced or not that they will not exert normal force? Both have a tendency to fall with an equal acceleration of g. Then why will one block push the other block? Generally, when will pushing happen? Okay, suppose you are standing in a line. When will someone push you if they want to go faster than you? Okay. So same thing with objects also. When the object which is behind tries to go faster than the object which is ahead, then pushing will happen. Yeah, but here these objects fall under gravity and gravity makes them accelerate at the same rate. So M1 will never try to go faster than M2. Then how much will the normal force between the blocks in this case be? It will be 0. Only their weights will be acting and they'll be falling down freely. Is this clear to all of you? Any doubt in this? Okay, now let us go back to this question. These two blocks were placed on a smooth incline. Angle of inclination was theta. My question was how much normal force acts between the blocks. We will first check if normal force needs to act between them. Okay. We know when we put two blocks on a smooth surface like this and release, both of them are going to slide down. So one of you tell me, had B not been there, okay, Forget B existed. Suppose only A was there. What would have happened to it? You kept a block on an inclined surface and left it. Surface is smooth. What will happen to it?
So fall down, slide down.
Slide down with what acceleration? You need to be more specific. We have learned some mechanics by now.
So 5 meters per second.
How did you decide it is 5? Anyone? First, see, my question was what acceleration will the block slide with? And acceleration depends on force acting, no? So you have to think in terms of force. I've been telling you this since we started this chapter. If you want to decide what happens to a system or how it is going to move, consider forces acting on the system. Can one of you quickly tell me what force makes the block slide down the incline? What force makes the block slide down the incline?
Sir, gravitational.
So you are saying mg, or will it be a component of mg?
Component of mg.
How do we write component of mg along the incline?
Mg sin theta.
Mg sin theta. In this case, it will be m1 g sin theta. That's the force which would pull it down the incline. If the force is m1 g sin theta, then the acceleration with which it would slide down the incline will be g sin theta. Okay, so had m2 not been there, m1 would have slid down the incline with an acceleration of g sin theta. Now you all consider m2 independently. Okay, so forget m1 existed for now. So let us erase m1. Suppose only m2 was there. Yusuf, you tell me what would have happened to it?
So the same thing that happened to M1 and happened to M2.
The force m2 g sin theta would have dragged it down the incline, due to which it would have accelerated at a rate of g sin theta again. Okay, earlier we found that had m1 been alone, it would have gone down with an acceleration g sin theta. Now we see that had m2 been alone, it would also have gone down with an acceleration g sin theta. So basically what is happening here is gravity is pulling both of them at the same rate. Okay, gravity is trying to make both of them go at the same rate, and we know there are no other agents pulling any of them down or pushing them down. Okay, both have to go down because of gravity only. So independently, under the influence of gravity, they go with acceleration of g sin theta and g sin theta. Then now you all tell me, is there a need for them to push each other when they are anyway tending to go at the same rate? Will they push each other?
Yes, sir.
Why?
Sir, they'll just be going around the same direction, right? Since the mass of M2 is bigger, so it'll be putting force on the M1 block.
See, it's not about mass, no. Whether one goes faster than, see, pushing will happen when one tries to move faster than the other. Trying to move faster or not will be determined based on acceleration. Okay, which is force divided by mass. The force on A, like, then in this case, why did you say it will not, they'll not push? Why did you agree that they won't push each other? Because, okay, you thought M2 goes faster, so M1 doesn't have to push M2.
Yes, sir.
No. In this case, had M2 been on top, even then the answer for normal force would have been 0. Okay, faster masses don't, heavier masses don't move faster under gravity. Okay, because gravitational force is mg. Then acceleration due to gravity will be force of gravity divided by the mass, which will be g, irrespective of mass of the object. Acceleration due to gravity is 10 meters per second square for every object. Okay, in real life, we sometimes see heavier objects falling down faster than very light objects Can one of you tell me why? Like if you drop a sheet of paper and any heavy object like a water bottle or something, the water bottle will fall to the ground faster than the sheet of paper. Why?
Sir, because of the gravitational forces acting, and the
No.
mass is also heavy. It's heavier, right?
See, let mass be heavier. If mass is greater, gravitational force will be greater. But the rate at which an object falls is not determined by the force, it's determined by the acceleration. Okay, and acceleration due to gravity is 9.8 or 10, as you have learnt. Did you ever learn that it varies from object to object? No. But still, in a real life situation, we see a light object like a feather or a sheet of paper falling to the ground slowly, whereas a heavy object like a water bottle falls to the ground faster. Why? If rate of acceleration is same for both of them due to gravity, why do we see one object falling faster than the other? Pawan, what do you think?
Sir, mass.
Arey, I'm actually surprised. How come you all are not giving answer to this?
Sir,
Any, now, those of you who think mass is the factor, consider this. Again, take a sheet of paper itself. In one case, take two sheets of paper, identical sheets. In one case, let the sheet be open like this. And in another case, you crumble the sheet of paper like this, make a ball. Drop both of them from the same height. Which will fall to the ground first? Rishi,
Paper
what?
ball.
The ball will fall to the ground first before the open sheet. But they are identical sheets. Both are A4 sheets taken from the same bundle. Okay, that means their masses are equal. But still you see one falling faster than the other. Now can you say it is because of mass? No, mass is not the factor there. Okay, the factor there is air resistance. Due to the presence of air, when something moves through air, air molecules exert force in the opposite direction. And greater the surface area, greater will be the resistive force. So on both these papers, gravity is the same, mg, mg. Okay, their masses are equal, so gravity will be equal. But on the sheet which has a greater surface area, there will be more air resistance. On the sheet which has less surface area, the crumbled sheet of paper will experience less air resistance. That is why it can move faster. Okay. And even if their masses had been different, okay, like in this case, you take two blocks, masses M1, M2. We discussed, I told both will have G only. Then why did you not ask me a question? The heavier mass should accelerate faster. Why are you saying G? Listen, gravitational force or weight of an object is mg. Yes, the force depends on mass. Heavier masses experience heavier gravity, greater amount of gravity. So if this is the force, acceleration becomes force per unit mass, no, force by mass. So send mass this side, then you will get only g, irrespective of mass. So if you ignore other forces and consider only gravity, all objects will accelerate at the same rate. Okay. Now let's go back to the question that I asked. Here also I told you that both will have acceleration g sine theta under the influence of gravity. You agreed to that, but later when I asked you if they exert normal force, you are saying yes. Some of you are saying yes. The answer is no. We know these blocks go down because of gravity. And if at all any normal force is generated between them, that also has to be due to gravity only, because gravity is what makes the block go down. And that tendency to go down can make it push on something else. Okay, like B has a tendency to slide down because of gravity. And if anything comes in its way, it will push it. But observe what is happening here. A has gravity acting on it. B also has gravity acting on it. And gravity pulls A and B both at the same rate of acceleration g sine theta. So in a given amount of time, whatever displacement A undergoes, the same amount of displacement B will also undergo under the influence of gravity. B won't try to go faster than A. Okay. And if B doesn't try to go faster than A, why will it push A? It will not. Okay. The normal force between the blocks in this case also will be 0. Think about this once again, all of you. If you have any doubt, you can ask. We imagined the situation with the blocks separately. Had only M1 been there, what would have happened? Had only M2 been there, what would have happened? And we find that they would have accelerated at the same rate if they had been alone. Now, if they are together also, they'll accelerate at the same rate only. No, gravity is still the same, whether they are together or separate. Okay. And because the block which is behind M2 doesn't have a tendency to go faster than M1, it won't push M1. So they'll both slide side by side without pushing each other. Okay, hope this is clear to all of you. If you have any doubts, you can ask.
Sir, sir, ఇప్పుడు మాస్ కి ఏమైనా వాల్యూ తీసుకుంటే
Okay, let's assign some value to mass. Okay.
M2 magnitude M1 కన్నా ఎక్కువే ఉంటుంది కదా సార్.
Let it be. Let M1 be 1 kg. Let M2 be 10 kg. So
అప్పుడు M2 జీ సైన్ థీటా చేసేటప్పుడు మీకు 10 kg ఫాస్టర్ గానే యాక్సిలరేట్ అవుతుంది సార్, అంటే మాగ్నిట్యూడ్ ఎక్కువ ఉంది కదా.
g sine theta doesn't have m in it at all. How does it depend on the mass?
కాంపోనెంట్ గ్రావిటేషనల్ ఫోర్స్.
Okay, wait. Let's consider the gravitational force acting on the block B. Okay, assume block A was not there. Saket, you only tell me. Let's call the mass as M2 itself. You don't even have to assign a value to it. How much gravitational force component acts this way? Generally, how much is the component along the incline? Component of weight along the incline?
mg sin theta.
So in this case, it becomes M2g sin theta. Let it be. That's the gravitational force. That's correct. What is the acceleration it gets due to this force? How do you calculate acceleration from force? Force divided by mass kada. F divided by M2. Then that becomes the acceleration becomes g sin theta itself. It's independent of the mass. So whether it's a 1 kg block or a 10 kg block or a 1000 kg block, it will slide down at the same rate. Did you understand?
Yes, sir.
Still, if any of you have doubts, you can ask. Their weights are different. The force pulling them down is different, but the acceleration at which they get pulled down is the same. So normal force between the blocks is 0. And see, I'm telling you a general way to check whether normal force acts between two surfaces or not. Visualize the surfaces independent of each other. Had M2 not been there, how would M1 have moved? Had M1 not been there, how would M2 have moved? Would they push each other if they are together? That is what tells you whether normal force acts between blocks or not. Okay. Let's consider another situation, somewhat similar to the first case. Two blocks placed on a smooth horizontal surface. Okay. Let's assign some masses. Suppose block A's mass is 2 kg and block B's mass is 3 kg. This time, we are applying some force from this side. Some extra force is being applied. Let's say some 20 Newton. Now tell me, will A and B push each other? Will they exert normal force on each other or not?
Yes, sir.
Okay, others also think and tell your give your answers. What happened? Others are not able to decide whether they exert each other on, I mean, they exert normal force on each other or not. Okay, Pawan, you're the one who said yes, no?
Yes, sir.
Why do you, or how can you say that they will exert normal force on each other this time?
Sir, surface మొత్తం హారిజాంటల్ ఉంది కాబట్టి అంటే ఫోర్స్ కూడా ఒక సైడ్ నుంచి యాక్ట్ అవుతుంది సార్.
Wait. Because the surface is horizontal, what did you say?
సర్ఫేస్ హారిజాంటల్ ఉంది, పైగా ఫోర్స్ అనేది ఒక సైడ్ నుంచి యాక్ట్ అవుతుంది.
Yeah, we are applying the force only from one side, correct?
సో ఏ అనేది బీని పుష్ చేస్తే వెళ్తుంది కదా సార్.
Force రెండు సైడ్ నుంచి ఉంటే, what if there was 20 Newton from the other side also? Will there not be normal force between them?
అప్పుడు ఉంటుంది సార్.
In that case also it will be there. Okay, fine. So listen, as I said, if you want to decide whether normal force acts between two surfaces or not, imagine the objects independently. Okay, so here let's ignore B and only consider A first. Okay, Yusuf, tell me, because of this 20 Newton, of course there are other forces also acting on A, its own weight 20 Newton will be acting, and normal force from the ground also will be there. So Yusuf, tell me, under the influence of these forces, which way is A going to move and with what acceleration is it going to move?
So it's going to move to the right.
And with how much acceleration will it move? What is the net force acting on A? How much is the net force acting on A?
సో 20.
Okay. See, you have to be comfortable with these. Practice the questions a little more. At least, okay, I'll send you the notes that we have, notes of all the classes that we have discussed till now. Whatever questions we discussed in class, go through them once again. Okay, I'm telling this to all of you, and solve problems from the worksheet also. Now here, there is one block on a smooth horizontal surface, and we are pushing it to the right. You said it will go to the right, means these forces cancel. Normal force and weight cancel, they get balanced. This will be the only unbalanced force. So the net force is 20. And if you know net force, then you can tell acceleration. A is equal to net force divided by the mass becomes 10 meters per second square. Okay. So the block A, had it been alone, would have accelerated at a rate of 10 meter per second square to the right. Hope this is clear to all of you. We are just trying to find out if there will be a normal force between them or not. Okay, so for that, I first visualized what will happen to A in the absence of B. It would accelerate to the right at a rate of 10 meter per second square. Okay, now let us bring B back into the picture. And let us now take A out of the picture. So had this block not been there, only B had been there. Can one of you tell me what would have happened to B? Just consider the forces that act on it.
In
and
rest, sir.
It will continue to be in rest. Okay, correct. Don't you think that 20 Newton will act on B? Or just a moment, listen all of you. Its weight is 30 Newtons and there will be a normal force on it from the ground. That's fine. They'll anyway balance. Okay. So this normal force balances the weight. There is no other force acting on B. So net force on B is 0. So had B been alone, B would not have accelerated. My question is, was that 20 Newton force acting on B also? Should we have considered that 20 Newton on B? From the diagram, or as seen in the diagram, on which object is 20 Newton acting?
A.
A. We are not pushing B directly, we are pushing A. Okay. And due to that 20 Newton, A would have accelerated at a rate of 10 meter per second square. And but B would not have accelerated. 20 Newton was not acting on B, no? So had B been alone, it would not have gone anywhere. Now see, both of them are present. A has a tendency to accelerate this way. B has no tendency to move on its own. Now tell me, will A push B or not? Will they push each other? Will there be a normal force between them or not this time?
Sir, when the 20 Newton is acting on A,
Yeah, 20 Newton is acting. Yes.
yeah, then there would be the normal.
Yeah, then they will be pushing each other. Okay, because A has a tendency to accelerate, B does not have that tendency to accelerate, which means B would be standing in the way of A. Then definitely A will push B. There will be a normal force that they exert on each other this time. Okay, so the answer, will A and B exert normal force on each other? The answer is yes. Now you have to find out how much normal force they exert on each other. Now, common sense, from everyday experience, you can tell if two objects are placed side by side like this and you push one of them, are both of them going to move together or not? Will they move separately?
They will move together.
Others also, what do you think? Will they move together or will they move separately? Pawan, what do you say?
Sir,
Will these two blocks move together or will they move separately with some gap between them?
sir, they will move together.
Okay. Saket, what do you say?
They'll move together, sir.
Fine. Correct. They will move together. See, A had a tendency to go at a rate 10 meter per second square. B didn't have a tendency to move at all. So now A will push B and they will move together. They will stay in contact. Let's say they move together with an acceleration of A. So this is like a constraint now. A has to push B, means they have to stay in contact, means they must move with equal accelerations. So the constraint is that acceleration of A is equal to acceleration of B, which is equal to A. Okay. So last class and the class before that, we discussed constraint relations with tension acting between the blocks. Now we are talking about constraint with normal force acting between the blocks. Okay. So for normal force to act, contact is necessary. For them to stay in contact, they need to move at the same rate. So they'll have a common acceleration now. And we need to find out how much normal force they exert on each other. You all told that A pushes B. So B experiences a normal force to the right. A will experience that same normal force, that same amount of normal force to the left. Action, reaction. Okay. Action is exerted by A on B. Reaction will be exerted by B on A. Okay. So this is the situation now. And they have a common acceleration. The question now is to calculate the normal force between the blocks and the common acceleration with which they move. Try this, all of you. The question is asking you to calculate a force and an acceleration. The only relation we have is F net equal to ma. Try to apply that. I'll give you all 2 minutes. Okay. Vanilla, your answer is correct. Okay. Listen, all of you. The blocks are on a smooth horizontal surface and you are pushing the set of blocks to the right. Definitely they will accelerate to the right. That we have already considered. And they'll have a common acceleration that also we have considered. You need to find out the normal force between them and that common acceleration with which they move. The only equation we have relating force and acceleration is F net equal to ma. That is what we have to use. Fine. Saket, tell me, what is the net force acting on B? I'm not asking the magnitude, but which force is the net force acting on B?
Sir, 20 newtons.
20 Newton is not acting on B. We are pushing A with 20 Newtons. How can you say B also experiences 20 Newtons? అంతే కదా, మనం ఏని కదా తోస్తున్నాము, ఏ వెళ్ళి బీని తోస్తుంది, అది ఎంత ఫోర్స్తో తోస్తుందని మనం కనుక్కోవాలి. Vanilla, what did you say? Okay, anyway.
3A.
Okay, in terms of mass and acceleration you are saying, but I'm asking which force? Which force is the net force on B? Okay, Saket, tell me what all forces act on B?
Sir, normal gravitation.
See, in this case, there are multiple surfaces of contact. You should tell normal from which surface also. Okay.
Sir,
Gravitational force will act, that is its weight. Okay. And
normal force from surface to B.
Okay,
B
from
top.
surface on B, that normal force will act, and
And A to B.
from A also, which we have represented in green.
Yes.
These are the three forces acting on it. Which way does B move?
Right, sir.
Right. Okay, from like everyday experience, we know it is going to move to the right. It means the vertical forces cancel each other or balance each other. Then now answer my question. Which is the unbalanced force on B?
Normal, sir.
That normal force from A is the only unbalanced force on B. So my first question was, what is the net force on B? Net force means unbalanced force. That N is the unbalanced force on B. So for object B, if you apply Newton's second law, the net force acting on it is that unknown normal force. You should equate it to its mass multiplied with acceleration. Vanilla said 3a, that is correct only, but I asked which force is equal to 3a. So N is equal to 3a. So we are applying Newton's second law to the block separately now. Because there are two unknowns, we need two equations to solve. So we'll write one equation for first block or for block B, another equation for block A. Okay, next equation will be for block A. Aishwarya, you tell me, what is the net force acting on A? Or first tell me what all forces act on A.
So gravity and the reaction force perpendicular to the surface.
Okay, gravity downwards, normal force from the surface, that will be upwards. And
So
obviously,
20 Newton and the reaction force to it.
yeah. And clearly there is this 20 Newton acting, and there will be an opposing force from B also. This N also will be acting on A. So there are four forces acting on A. Okay. Aishwarya, which way is A going to move?
So towards the right.
Towards the right. So vertical forces will cancel. Okay. Acceleration is horizontal, so vertical forces cancel. So 20 remains and N remains. Then what is the net force towards right? Or how would you write the net force towards right?
So 20 minus N is equal to 2A.
Correct. 20 is to the right, N is to the left. So net force to the right will be 20 minus N. That will be its mass multiplied with acceleration. That's all. You need to solve these two equations and get N and A from them. So N is 3A, substitute that here. 3A goes to that side, you get 20 is equal to 5A. That means acceleration is 4 meters per second square. And the normal force between them is 3 times of acceleration, so 12 newtons. Okay. See, this is a very common mistake that students make. We are applying force on block A. Many times students think that that force acts on block B also. No, 20 Newton force doesn't directly act on B. The push that A is giving is what acts on B. And A doesn't give a 20 Newton push to B. We have found that A gives only a 12 Newton push to B. Okay. Is this clear to all of you? Any doubts in this? So you were given two blocks placed side by side and force acted on one of them. You were asked what will happen to the system. Okay. So first thing we did was visualize the motion of the block separately. We imagined B was removed from there. Then we found that A goes with an acceleration 10 meter per second square. We imagined A was removed and the forces acting on it were removed. Only B was there. We found B will not be moving. So A has a tendency to move. B doesn't have a tendency to move on its own. That means A pushes B. That means there will be a normal force generated between them. Okay. Then we visualized that normal force and wrote Newton's second law, including that normal force, and we got its magnitude. So you could have solved this question this way also. The situation given to you was like this: two blocks placed side by side with some force acting on them from one side. Okay. From everyday experience, since they are solid objects, we know that they are going to go with a common acceleration. Now, not just in this case, in any case, if you are sure that objects are going to move with a common acceleration, you can consider both of them as one system. Because if both are going to go together, why not take it as a 5 kg block? You can. Okay. Okay, maybe I should not call it a block, whatever it is. Why not take it as a 5 kg object? You can. So had it been a 5 kg mass, its weight will be acting, normal from the ground will be acting, but they'll balance. The only unbalanced force is the 20 Newton. So now if you write net force is equal to mass into acceleration, you will still get the same acceleration of 4 meter per second square. That is the answer we got before. Okay, when we took blocks separately. But if you are sure that they are going to move with the same acceleration, then you can take the entire system as one object. Okay, you can take the collection of blocks as one object and tell the acceleration directly. But in the question you were asked what is the normal force between the blocks also. For that you will have to take them separately. Okay, once you get this acceleration 4 meter per second square, what gives this acceleration to the block B? The normal force itself. Normal force from A, the push given by A is what makes B accelerate. So now you can say that normal force which acts on B is its mass multiplied with its acceleration. That way also you could have calculated normal force as 12 newtons. So first getting the acceleration based on the fact that they move together, and from that deriving the unknown force. That is also possible. Okay. So there are two ways of approaching such questions. That is what I'm telling you basically. You can, like right from the beginning, you can treat them separately, or you first treat them together, find out the acceleration, then separately you deal with them, you write equations for them, you can tell the unknown force. You could have written equation for A also. On A, there will be a normal force acting this way, 20 Newton acting to the right. So you would have written 20 minus N is equal to its mass multiplied with its acceleration, that is 8, which again gives you normal force as 12 newtons. Okay, so if you are sure that objects are going to move together, you can do this. Let's try one more question like this. Let's say there are 3 blocks this time. Masses, let this one's mass be 1 kg. B block, let its mass be 2 kg. And C also let it be 2 kg. We apply a force of 40 Newton from this side and a force of 10 Newton from the other side. Okay, slightly complicated situation, more blocks, more number of forces, but I think you will be able to do it. One of you tell me, based on your visualization, what is going to happen to this system of 3 blocks?
Or it'll move towards the right.
Will they move together or will they separate?
Together only, sir.
Together. Okay, it's like someone is trying to push the system from right, someone is trying to push the system from left. The one pushing from left is exerting a greater force. So the 3 blocks together will go to the right. This is right for me. So the 3 blocks together will go to the right. So you are sure, I mean, you can tell for sure that they will move with a common acceleration. Okay. Now the question again is similar. What is the acceleration with which the blocks move? What is the normal force between A and B? I mean, how much? And how much is the normal force between B and C? Do this quickly, all of you. Type all 3 answers together in chat. Okay, I got one answer just now. Acceleration of 6, normal force of 34 Newton. One normal force 34 and the other 22. We'll see. Got another answer as acceleration 6, one normal force has 24, the other has 28. Your answers for acceleration are correct only, but normal force, no. Vanilla, check your normal force calculations, both are wrong. Saket, your that 28 Newton answer is wrong. Okay, wait, I think both are wrong. Just a second. Okay, Vanilla, your answers are correct. Saket, your answers for normal force are wrong. Yeah. Listen, all of you, since we know that the system is only going to move horizontally, you don't have to consider their weights and normal forces at all. I mean, normal force from the ground you don't have to consider at all. Only look at the horizontal forces acting and write equations accordingly. Okay, fine. Listen. Pawan, can you unmute?
Yes, sir.
Tell me all the horizontal forces acting on A.
For normal force
From?
and 40 newtons from B.
Ha. So A will experience a normal force from B like this. Okay, in fact, it will be better if you visualize the objects separately. On A, there is a 40 Newton force acting, obviously, to the right. Along with that, there will be a normal force acting to the left. This comes from B. That's the normal force between A and B. Any other force that would act on A, Pawan? Any other horizontal force that would act on A?
No, sir, nothing.
Will C exert any force on A?
No, sir.
It will not. C is not directly in contact with A. C will not exert a force on A. These are the forces acting on A. Okay. Next, Vanilla, tell me what forces act on B? Horizontal forces.
NAB and NBC, sir.
Okay. From A, there will be a normal force. From C also, there will be a normal force. From A, it will be to the right. Its magnitude is NAB itself. And from C, there will be a force to the left. We don't know which one is greater. These are the horizontal forces acting on B. 40 Newton doesn't act on B. 10 Newton also doesn't act on B. Just the press that A gives B will act on it, and the press or the push that C gives B will act on it. These are the two horizontal forces that would act on it. And then object C. Saket, tell me what forces act on C horizontally.
Sir, 10 Newton towards the left and normal BC, sir.
Okay. Normal force from B that will act to the right. That's all. These are the horizontal forces that act on each one of them. And under the influence of these forces, each block gets the same acceleration A. That's all. You just have to write Newton's second law now. Yusuf, tell me, how will you write Newton's second law equation for the first block, A? How will you write Newton's second law equation for the first block? Okay, Aishwarya, you tell.
So 40 minus n of AB is equal to A.
Okay. 40 minus normal force between A and B, I'm calling it as N1, equal to?
A, sir.
Okay, mass into acceleration. Mass is 1 kg, so 1 into A. Fine. Aishwarya, tell me the equation for B.
So n of AB minus NBC is equal to A. 2A.
Okay. N1 minus N2 is equal to its mass multiplied with its acceleration. And for C?
Sir, NBC minus 10 is equal to 2.
Okay. That's all. Now, you have to solve 3 equations. There are 3 unknowns this time, N1, N2, and A. Some of you may have felt that to be difficult, but the procedure is the same. Take one unknown from the first equation, put it in the rest of the equations. Then take another unknown from the second equation, put it in the third equation. That is one way to do. There are other ways also. If you like get used to solving equations, you will find them easy. So what I'm asking you to do is take N1 from the first equation. 40 minus N1 is A, so N1 becomes 40 minus A. What you'll have to do is you'll have to put 40 minus A here. Then the equation becomes 40 minus A minus N2 is equal to 2A, which means 40 minus N2 is equal to 3A. Now take N2 from here. 40 minus N2 is 3A, so N2 becomes 40 minus 3A. Put that here. 40 minus 3A minus 10 is equal to 2A. So 30 is equal to 3 plus 2, 5A. You get acceleration as 30 by 5, 6 meters per second square. That's correct. Okay, that is one way to solve. I told you another way also in the last case itself. If you know that all parts of the system are going to move together, you can treat it as one large object. If you do that, the force from the left is 40, the force from the right is 10. There are forces inside. One force acts on A this way, one acts on B this way. One force acts on B this way, one acts on C this way. Listen, all of you, this point is very important. This set of normal forces between A and B and this set of normal forces between B and C are called internal forces of this system or to this system. Obviously, I hope you understand that word internal forces. A part of the system exerting a force on another part of the same system becomes an internal force. Okay, A, B, and C are all part of the same system. Force exerted by A on B will be internal to that system. By B on A will also be internal to the system. So these two sets of forces will be internal forces. And see, we know for every action there is an equal and opposite reaction. If action force is internal, like exerted by A on B, reaction force will also be internal only, exerted by B on A, and they'll cancel. Okay, on the system as a whole, they will cancel. So what I'm saying is, I'll take this diagram separately. Normal force by A on B and normal force by B on A, this set is a set of internal forces whose resultant is 0. Why is the resultant 0? Because they are an action-reaction pair, no? They'll have the same strength but opposite direction, so their resultant will be 0. Similarly, normal force by B on C and normal force by C on B. To the entire system, if you see, they are another set of internal forces whose resultant is 0. Okay, so take this for granted. The resultant of all internal forces on a system will always be 0. Why? Because if you consider one of the internal forces, the reaction to that will also be inside the system itself. And the action and the reaction, since they have the same strength and opposite directions, on the whole system, if you see, they won't show any effect. Individually on the blocks, they will show effect. For example, that green arrow that I have drawn on A, this force, only on A, it's an external force. But ABC system together, it's an internal force. Okay, and internal forces don't affect the overall motion of the system. They may affect individual parts motion, but overall motion of the system, they won't affect. You'll understand this better when we talk about something called momentum conservation and all. Okay, since this is the first time you're listening to these terms, you may take some time to grasp all this, but you will get used to it, don't worry. So in summary, what I want to say is the internal forces, the resultant of all internal forces on a system is always 0. Okay, now look at the external forces acting. There's 40 Newton acting from the left, 10 Newton from the right. Vertical forces we are not considering. Therefore, the net force on this system is 30 Newton. And we know the mass of the system, 1 plus 2 plus 2 is 5 kg multiplied with A. So you get the common acceleration as 6 meters per second square this way also. I guess some of you did that. Okay, you gave acceleration answer correct only, but normal force answer you did not give correctly. So if you take the system together, you get an acceleration 6. Now the next part of the question, you have to find out the normal forces individually. Write F net equal to ma for any one of the block, that will be enough. For example, take C. For C, if you write net force is mass into acceleration, you're going to write normal force, we called it as N2, minus 10 Newton is its mass multiplied with acceleration. And we got acceleration as 6 meter per second square. 2 into 6 is 12. So N2 becomes 10 plus 12, 22 Newtons. That's all. Suppose you want to find the other normal force also. Write the equation for A. For A, if you write the equation, 40 minus N1 is its mass multiplied with acceleration. That's all. So N1 becomes 40 minus 6, that is 34 Newtons. Once you get the acceleration, you can tell the forces. I mean, you can calculate the forces. Is the solution clear to all of you? If you have any doubts, you can ask. Or if you have written any equations and you want to know why that equation is wrong, also you can ask. Okay. So let's quickly go through what we had discussed today. We just discussed cases with normal force between the blocks. And first I told you an idea to verify whether normal force acts between two objects or not. How do we do that? Consider or visualize motion of each object independent of the other object. Like imagining the other object was not there. So here if you visualize B is not there, A will stay there itself. First question. And if A is not there also, B will stay there itself. They don't have a tendency to move. So if you put them together also, they won't have a tendency to move. Why will they push each other? They won't push. So normal force between the blocks is 0. Next, this case we took. Here also we imagined what would happen to one block in the absence of the other block. And we concluded that both naturally will have a tendency to go down with an acceleration g sine theta. They'll naturally tend to go with equal acceleration. And if they have a tendency to go together, I mean, not together, if they have a tendency to move at the same rate, why will one push the other? They'll move together at the same rate. Okay. So here also normal force is 0. Then we visualize this case also. Two objects left under gravity. Both have the tendency to fall with the rate g. None of them is trying to go faster than the other. So they'll keep falling together, no normal force between them. They won't push. Then these cases, we found that they will push each other and we found out how much normal force will be acting between them. Okay, so we'll stop it here for today. We don't have time to start discussing about friction. Make sure you solve the worksheet that I sent yesterday, all of you. And Tomorrow I'll send you one more worksheet based on questions like this. Okay, 3 or 4 blocks connected by strings or pushing each other. Okay, maybe a combination of both also. Fine. Thank you all. We'll continue in the next class.